Good day to everyone. Today we are going to discuss our first topic for the subject EnggPhys or Physics for Engineers. So in this topic we are going to discuss all about vectors, and with that, so next we have your triangle method. So the triangle method is an algebraic method. So it's only applicable for two vectors. So why two vectors but triangle has three sides? So the third side of our triangle will be our resultant or your equilibrium. So depending on the form triangle of your vectors and the resultant, we will now use the following formula. So if it's forming a right angle, we now use your Pythagorean theorem. So if this is my first vector, second vector, and our resultant, then we use your Pythagorean. Or if we have now a triangle like this, so we have an acute and obtuse angles, we now use your sine and cosine laws. So for sine law, we have a over sine a equals b over sine b equal to c sine of c. Then for our cosine law, that's a squared plus b squared plus c squared minus 2 bc cosine of a. So you're familiar with this already from your trigonometry. Okay, so to understand triangle method, let's solve an example. So for the given vectors, let's solve our resultant. So let's use the same example as for the parallelogram method. Example number 1. So we have 15 kilometers, 30 degrees north of east. B is 10 kilometers, 27 degrees south of east. So for us, or to help us with our analysis, we can draw our triangle method. But when drawing your triangles for the triangle method, we follow the tip to tail. Okay, we connect our vectors. So we have here your 15 kilometers. So no need to scale it. Okay? Kasi math nang gagamitin natin, hindi na graphical. So kahit hindi sakto, approximation na lang. So we have 15 kilometers, and then for B, we'll have 10 kilometers. So we have here our triangle. Okay? So before we could identify which formula we could use, we have to identify first our interior angles. So we have north of east. So from east to north, 33 degrees. So this one is also 33 degrees. And then we have 27 degrees south of east is this angle. So the interior angle now between the two given vectors is theta. And we can solve theta now simply as 180 minus 33 minus 27, which will give us a value of 120 degrees. Okay? So, since the angle formed by the two given vectors is not a 90 degree or a right angle, then we will now use your sine and cosine laws. So, with that, I'll have now this angle as phi, and I'll have now r squared, which is unknown, is now equal to 15 squared plus 10 squared minus 2 times 15 times 10 cosine of the angle opposite our resultant, which is 120. And it will give us a value of 475 square kilometers. So the r now is equal to 21.79 kilometers. So for its direction, I'll be using this angle phi. So I'll be using the angle from our origin. So how will I identify that? I'll be using now our sine law. So we have sine is equal to 120 divided by r. So since alam ko ito, na-solve natin ito. So So opposite of phi is 10. So phi now can be solved as 23 degrees 41 minutes. Or, so ito lang yon, okay? So hindi pa ito yung ating final angle. Kasi ang mini-measure natin na angle is the angle between this blue line representing the resultant and the angle between the horizontal. So, what will I do? Ano ba tong value na ito? So, that will simply be the angle between vector A minus phi. So, graphically na yun. So, that will now be 33 minus 23.41, which will give us 9.59 degrees. So, therefore, the resultant of vector A and B using triangle method is 21.79 kilometers, 9.59 north of east. Okay? From the parallelogram method, the answer was 21.6 kilometers, 10 degrees north of east, which is very near our computed value. So, which is more accurate? It is the triangle method. Okay? So, mas accurate ang triangle method compared sa parallelogram or sa polygon method. Okay? So next we have the last method for our vector addition, which is component method. This one is the most accurate method for adding our vectors. So this is applied for any number of vectors. So it could be applied for 2 or more. Okay, so this is applicable only if the vectors are non-collinear. So how do we perform now addition by component method? So basically, we have here your vector A. So any vector. So it will have a magnitude and a direction. So this vector now can be divided into components. So we have what we call your AX, or the X component along your horizontal or x-axis. And then we have your y component, or your AY for this matter. So it's along our y-axis, or the vertical direction. So in here, as you can see, we can now form a triangle in terms of our AX and our AY, or our X and Y components. So with this, we can now compute for our X and Y components. So if our angle is measured from the horizontal, so let's call this theta, then our AX, or our X component, now can be computed simply as the magnitude of the vector times the cosine of the angle between the horizontal and your vector, or simply theta. And then for our y component, that will now be equivalent to the magnitude of a sine of theta. Okay, so it's simply trigonometry here. Okay, and then if our angle now is measured from the vertical, so let's call this angle phi. So the angle between your given vector and the vertical now is phi. Then our x component now will be computed as a sine of theta, or the magnitude of the vector, times the sine of phi, and then we have for your y component, that will now be equivalent to a, or magnitude of the vector, cosine of phi. Okay, so that is if the given is the direction and the magnitude of your vector. So what if we are given already, or instead are the x and y components? So for that matter, for the magnitude, we simply apply our Pythagorean Theorem. So the magnitude now of your vector is equal to the square root of your x component squared plus y component squared. Okay, and for our direction, so we'll just simply apply our tangent function. So theta now is equal to the inverse tangent of y component divided by your x component. And if we want it to be measured on the vertical, or from the vertical, then phi now is computed as the inverse tangent of the x component divided by your y component. Okay, but for us to be uniform, let us always measure our angles from the horizontal, para konti na lang yung ating i-memorize, or konti na lang yung formulas na kailangan nating tandaan. So that is now, if we'll be consistent that our angles will be measured from the horizontal, then we'll have now x component as a cosine theta and y component as a sine of theta. And for our direction, that's simply inverse tan, or arctan of y over x. Okay, and then you apply your north of east, south of east, or north of west, or south of west, depending on the direction. Okay, so to understand component method, let us solve an example. So let's determine the resultant for the given vector, which is taken from example 1 of our parallelogram method. So we were given vector A at 15 kilometers, 33 degrees north of east, and vector B is 10 kilometers, 27 degrees south of east. So in here, we can get or compute for our x and y components separately. So for vector A, so we know this is now 15 kilometers, 33 degrees. So we have your AX and your AY. So, or the x component of a and the y component of y. So, for ax, that's now equal to 15 cosine of 33, as we know that this angle is 33. Okay, so computing ax now is equivalent to 12.58 kilometers. And then for ay, that will now be computed as, since the angle is taken from the horizontal, that's equal now to 15 sine of 33. And computing this from your calculators, ay now is equivalent to 8.17 kilometers. Okay? And then we move on to our next vector, b. So for vector b, it will also have its x component and its y component. So for ax, it's again measured from the horizontal south of east. So this one is 27 degrees. Ax now is equivalent to 10 cosine of 27, giving us a value of 8.91 kilometers. And for ay, that will now be computed as 10 sine of 27, equivalent to the value of 4.54 kilometers. And this value should be a negative value. Why negative? Since our y component or the vertical component of b is along the south, which is the same as our negative y. So for this way of computing, we will have to check our sign conventions. So for ax, it's in the east, so it should be positive. Okay, correct. And then for ay, it's along the north, so it's positive, correct. Ax is on the east, so it should be positive. So ay, pag kinompute natin siya simply as 10 sine 27, ang lalabas lang dito is 4.54 kilometers without any signs. So you have to check. It's south, kaya kailangang negative. Okay, so don't forget that. So, okay. With this, once we have computed for our x and y components for all of our vectors a and b, we can now compute for the magnitude of the resultant. So first, we compute for your Rx resultant of the x component by simply adding up our x components, ax and bx. So that is now 12.58 plus 8.91. So we have 21.49. It's a positive value. So therefore, its direction is in the east. And then for Ry, the resultant in the y direction, so we'll have ay plus by. So we have now 8.7 plus negative 4.54. So it will give us a value of 3.63 kilometers. And it's a positive value, so its direction now is in the north direction. So this is not our final answer, since for the resultant, as I have said, if we're given the x and y components, we'll now apply our Pythagorean Theorem. So r now is equal to rx squared plus ry squared, or the resultant or magnitude of the resultant is equal to 21.79 kilometers. So we're not yet finished because we still have to compute for the direction of our resultant. So for our direction, so ang sabi natin, we want to be consistent. We measure our angle from the horizontal. So for the direction, we'll now use arctangent of ry over rx. So we just simply substitute your rx and ry in this equation. So theta now is equal to 9.59 degrees. And since it's from the horizontal, that will now be north of east. Okay? So from our example 1, using parallelogram method, we have 21.610 degrees. And then we have from the triangle method, it was 21.75, 9.59. North of east. So if you can see, the triangle method and the component method would give us almost exactly the same value. So there would be some discrepancies now between triangle and component method depending on our rounding off. So dito sa parallelogram, medyo malapit siya doon sa mas accurate na value. So medyo accurate na tayo sa graphical method natin. Okay? So let's solve another example to further understand component method. So let's determine the magnitude and direction of the resultant for the given vectors from the example number 2 of polygon method. So the given vectors were A, 2 kph, 45 degrees north of east. Vector B is 2.8 kph, 58 degrees east of south. C is 5.1 kph, west, 28 degrees south. And D is 3.2 kph, north, 18 degrees west. So instead of me individually computing for the x and y components, kagaya nung sa first example natin, para mas maayos, mas madali natin siyang i-compute, we could use a tabular form. So in this sense, we'll have now the first column as our vector. So the next column is the magnitude, followed by the angle made by the vector from the horizontal. Then we have here your x component. So since our angle is measured from the horizontal, x component now is equal to a cosine of theta. And for our y component, that will now be equivalent to a sine of theta. So for our vectors, we have 4. So we have vector A having a magnitude of 2 kph and its angle now from the horizontal. So from the east, so it's the horizontal, our angle is 45 degrees. Okay, next we have vector B, which is 2.8 kph. So in here, we will not use 58 degrees, okay, since we want our angle to be from the horizontal. So dito sa vector B, yung 58 degrees is from the south, which is your vertical. So for our angle, that will now be 90 minus 58. Next, we have vector C, which is 5.1 kph in magnitude. So in this vector, the direction is from the west. So that's your horizontal. So we simply use 28. And then for vector D, we have the magnitude 3.2. And our angle is measured from the north. Okay. So meaning, I'll have to compute for theta as 90 minus 18. Okay, with that, we can now compute for our x and y components. So let's compute first for our x components. So for vector A, x component now is equal to 2 cosine of 45, giving us a value of 1.414 kph. And then we have for B, that will now be 2.8 cosine of 32. So that's 90 minus 58 is 32. So if we're going to compute this, input this in our calculators, this will give us a value of 2.374 kph. For vector C, that is now 5.1 cosine of 28, giving us a value of 4.503 kph. And for vector D, that is now 3.2 kph cosine of 72, equivalent to 0.989 kph. So as you can see, all our values are positive values. But if we're going to check our vectors, we have now east and west directions. So we have to check this one. So for vector A, it's in the east direction, so it is a positive value. B is east, so that's also positive. C is west, so that should be negative. And D is also in the west, so that should be negative. Okay? So whenever we measure our angles from the horizontal or the vertical, we always make sure that we check the sign conventions of our x and y components. Okay, so next step, we compute now for your y component using this equation. So for A, that will now be 2 sine of 45. So that's equal to 1.414 kph. B is 2.8 sine of 32. So that will be equivalent to 1.484 kph. C y now is equal to 5.1 sine of 28, which is equal to 2.394 kph, and dy, or y component of d, is 3.2 sine of 72, giving us a value of 3.043 kph. So again, we check our sign conventions. Vector A is north, so that should be positive. Vector B is south, so that should be negative. C is south, so that is negative. And D is north, so that should be positive. So once we have computed all of our x and y components, we now compute for our sum of the components. So for x component, Rx now is equal to negative 1.704. So we add it up together with the sign convention. So the negative sign here demonstrates that Rx is in the west direction. And then for our y component, add them algebraically together with their sign conventions. So Ry now is equal to positive 0.79 kph. So the positive sign for this value represents that we are in the positive y direction, which is our north. Okay, so once we have computed for your Rx and Ry, we can now solve for our magnitude. So for the magnitude, it's now equal to the Pythagorean Theorem, Rx squared plus Ry squared, and take the square root. So this will give us a value of R equal to 1.799 kph. And for our direction, since we are in the horizontal, or our reference is the horizontal, so the direction now is equal to the arctangent of Ry divided by Rx, or theta is equal to 18.767 degrees north of west. So if we're going to compare our computed answer using the component method to our answer from the polygon method, that was 1.8 kilometers or kph, and that is 20 degrees north of west. So we have 1.8 versus 1.799, and we have 20 versus 18.767. So they're almost the same, but it's more accurate, or the more accurate answer is from our component method. So okay, let's solve another example for component method. So determine the magnitude and direction of the resultant for the given vectors. So we have vector A, 17 newtons, 83 degrees north of east. B is 44 newtons, 13 degrees east of south. C is 25 newtons, 74 degrees west of south. D is 30 newtons, 43 degrees west of north. And lastly, we have 32 newtons due north for vector E. So let's use again our tabular form in our solution. So we have vector, we have the magnitude. So we'll have here our angle. So as you can see, this is from the east already. In the previous problem, we have our angles measured from either east or south. For this problem, we'll only be having one reference, which is our east, or the 0-degree reference. Okay, so next we have your x component, which is equivalent to the magnitude cosine of theta, and y component is equal now to the magnitude times your sine theta. So we start off first with vector A with magnitude 17 newtons. So its angle from the east will be equivalent to 83 degrees. Then we have vector B, which is 44 newtons. Its angle now is 13 degrees east of south. So it means that from the south, we move 13 degrees towards the east, or that's equivalent to 270 degrees plus 13. Next, we have vector C, which is 25 newtons. So its direction is 74 degrees west of south, or that means from the south, we move 74 degrees to the west, or that is now computed as 270 minus 74. Next, we have vector D, which is 30 newtons. Its direction is 40 degrees west of north, or it means from the north we move 43 degrees to the west, so that will now be equivalent to 90 plus 43. Lastly, we have vector E, which is 32 newtons in magnitude, and the angle now will be equivalent to 90 degrees as the direction is due north. So once we have now identified our angles measured from the east, then we'll have our x and y components. So let's start off first with the x component. So ax, that's now equal to 17 cosine of 83, giving us a value of positive 2.072 newtons. Bx will now be 44 cosine of 283, and that's equal to positive 9.898. Cx is 25 cosine of 196, equal to negative 24.031. Vector dx is now equal to 30 cosine 133, equal to negative 20.460. And ex is 32 cosine of 90, equal to 0. So if you have observed, in our values now using the angles measured from the east, there is already an included sign convention. So if we're going to check, ax is positive since it's along the east direction. Bx is also in the east, that's why it is a positive value. C is a negative value. Is it in the west direction? Yes, so it's correct. And then we have D is in the negative direction, so it's also in the west. Okay, so if you're going to compare this later on, if instead of using angles from the east, but I'll have it based from the angles, ang difference lang nung measured from the east and measured from either east or west is that in our previous problem, nag-compute muna tayo ng values ng x and y components. Saka natin chinek kung ano yung sign conventions depending on the direction. Dito naman, because we have established that our start is the east, which is your 0 degrees, nabibigay na niya kung ano yung equivalent directions or yung equivalent sign conventions ng ating direction for the x component as well as for your y component. So let's check it later on. Okay, so let's move for the y component. That will now be 17 sine 83, and that will give us positive 16.873. B, y is 44 sine of 283, equal to negative 42.872. cy is 25 sine of 196, equal to negative 6.891. dy is equal to 30 sine of 133, and that's equal to positive 21.941. And we have ey, which is equal to 32 sine of 90, equal to positive 32. So if we're going to check again, A is in the north, that's why it's positive y. B is in the south, that's why it's negative here. C is in the south, so it's negative. D is north, that's why it's positive. E is north, that's why it's positive. Okay, so it's up to you if you want to use the method or the process in the previous problem or this process. Okay, so any will do. Just remember that if you're going to measure it either east or west, you have to check your sign conventions. Hindi lang yung diretsong sagot. Okay? Pag gagamitin naman natin is angle from the east, you have to make sure that your angles or computation of the angles is correct in order for us to give or compute for the correct value and the correct sign convention. Okay? So, then, once we have now computed for your x and y components, we can now compute for your total x and y. So, for our rx, just simply add this up, and it will give us negative 32.521. wherein negative for the x is equivalent to the west direction. So for our y, simply add this up. Our y now is equal to positive 21.051, wherein the positive is equal to the north. Okay? So with that, given now Rx and Ry, we can now compute for our resultant, which is equal to the square root of Rx squared plus Ry squared, in which R now is equivalent to 38.740 newtons. And for our angle, the angle now is equal to the arctangent of Ry divided by Rx, and that will give us a value of 32.915 degrees, and that is north of west. Okay, so that's it for vector addition. Okay, so that's it for module 1 vectors. So I hope you have learned or have additional knowledge based on your readings of module 1. So if the examples are kulang, then there are more examples in the module, you can review them. Okay, so the activities for module 1 will be uploaded in the classroom. Just wait for it. Okay, again, thank you for listening.